Okay, so this is my presentation for Lab 1. So, the purpose of this lab is to understand tape, but more importantly, the relationship between gravitational force and electrical force, and to have a deeper understanding of how charge works within different interactions, specifically like household items and how things can naturally procure charge and have charge, and how that might affect its physical properties. So the fundamentals of this lab that they're looking at is the electrical force, which is kappa times charge over the distance squared, and the force of gravity, which is just mass times 9.8. So the idea of this experiment is that everyday objects can acquire negative charge from contact or ripping or things like that, because electrons, ions are just moving around, having a grand old time. And so, for instance, in this experiment, we're looking at tape being ripped apart from one another to create this negative charge. And therefore, we're going to find that tape behaves differently with different objects after it is negatively charged. That should say negative. So the results of this experiment is that, we had the negatively charged tape in hand. It was attracted two negatively charged tape things together. They were not attracted to each other, they were repelled. And when we had held the tape up to like a bench, it was attracted. Okay, and so another portion of the experiment was the whole floating tape thing. So it was stacking a piece of tape on top of another negatively charged piece of tape, and since they're both negative and stacked on top of each other, the electric force should equal out with the gravitational force and make a floating tape. This is my diagram that I made. I think it's good. So then this gives the equation that the electric force equals the gravitational force, and the tape can be modeled as a single point or as a line of point charges, which is where the coding section of the lab comes in. And the difference in the models will give different speculations of the actual charge of the tape. So for the point model, we had 9.33 times 10 to the negative 9th coulombs, and for the line model value, we got 3.04 times 10 to the negative 9 coulombs. So I'm just gonna run through some of the questions that the lab was asking. What is the length of your tape? About 20 centimeters or 8 inches. Clear tape is around 1 gram per meter, so the mass of our tape was like 0.02 grams. The distance between the two tapes we got was 2 centimeters. What was the magnitude of the gravitational force? 1.96 gravitational units, kilograms times meters per second squared. What was the magnitude of the electrical force on the floating tape? That would be the same as the gravitational force. What is the measured electric charge on the tape? We got the 9.33 times 10 to the negative 9th coulombs. Yeah, I'm not sure about any other relevant questions. Okay. And then the computational was on the previous slide. And then what assumptions, approximations, or idealizations did you have to make to determine the amount of charge floating tape in each model? Well, obviously we had to ignore things like the air and anything that might impact the electric charge or the gravitational force, because it was very simple, idealized. Oh, I'm running out of time. Yeah, we just kind of focused on those two forces, and also that every single ion got like ionized. And then what if and why? Electrons are negatively charged. What if they were swept? Then most things would reverse. I don't think that the tape would be attracted to the bench or to the hand, but I do think they would still repel because they would have the same charge. And then, why are we getting two different answers? Well, it's because the line model and the point model are obviously different. Thinking about a ton of point charges consecutively together that would all have like smaller charges, as opposed to like one big charge that's repelling each other. they're gonna have different outcomes. I think the line charge is more accurate because I think it more resembles what happens in nature, I suppose, because it's like a bunch of charges right next to each other instead of just one. And then what are some errors? So we had our experiment outside, which was tough because of wind, it was hard to see. The surface could have been charged that we were using. Our hands kept touching the tape, which might have messed with the charges, and it was difficult to tell when the tape was floating to make the measurement. Okay, ran out of time. Yes.